the remainder and factor theorems. Let P of x and D of x be polynomials where D of x equals x minus alpha, where alpha is a constant. Then P of x divided by D of x will result in a constant remainder R of x, since the degree of R of x is less than the degree of D of x. And we can see that the degree of D of x is 1, therefore the degree of R of x is 0, hence it's a constant polynomial. When P of x is divided by D of x, where D of x is a linear polynomial of the form D of x equals x minus alpha, where alpha is a constant, the remainder R of x is equal to P of alpha. And that's very convenient because we don't have to use long division to determine the remainder. So for example, find the remainder when x cubed plus 2x squared minus 5x minus 13 is divided by x plus 3. So this is our P of x, this is our D of x. Our alpha in this case will be negative 3. In fact, I might just write that in. So alpha is equal to negative 3. Now, expressing this division in dividend divisor quotient remainder form, we have P of x is equal to x plus 3, since we know what the divisor is, times some quotient, which we don't know what that is because we haven't done the long division process, plus some remainder, which we're trying to determine. So moving on, if we substitute P of negative 3 into this expression, we have P of negative 3 equals negative 3 plus 3, multiplied by Q of negative 3 plus R of negative 3. So negative 3 plus 3 obviously gives you 0. So P of negative 3 is equal to 0 plus R of negative 3. Now P of negative 3 can be determined by substituting negative 3 into P of x. Hence R of negative 3 is equal to negative 3 all cubed plus 2 times negative 3 all squared minus 5 times negative 3 minus 13, and therefore the remainder is equal to negative 7. Now more formally, given polynomial P of x and divisor D of x equals x minus alpha, where alpha is a constant, then the remainder of P of x divided by D of x is P of alpha. And this is the remainder theorem.